Today I'm here to teach you another concept of moles, and that is moles in solution. So first of all, we need to understand what is a solution. Solution is basically a mixture which is made up of solute and a solvent, right? So what is a solute? Solute is something which is dissolved in solvent. And what is solvent? Solvent is something which is dissolved in dissolving the solute. Now, for example, if I have NaCl solution, right? Or I can say I have aqueous sodium chloride, right? So in this, the solute will be, in this, the solute is going to be your NaCl. And because NaCl, because that's a solute which I'm dissolving, right? And NaCl will be my solute, and in the substance in which I'm dissolving, that's a water. So water will be the solvent. So NaCl being a solute is dissolved in the solvent water, or water as a solvent is actually dissolving the solute NaCl. So that is why we call it aqueous sodium chloride, or we call it NaCl solution, right? Is this much clear? Fine. Now we are going to talk about the moles in the solution. So the solvent is taken in DMQ. We always take the solvent's volume as basically in DMQ, right? Because this is a liquid in which the solute can be dissolved. Now solute can be taken, the amount of the solute can be taken as the amount of solute can be taken in the form of a mass, or it can be taken in 2 moles. If the solute is taken in mass and is dissolved in the solvent, okay, is dissolved in the solvent, then we call it a gram concentration. Okay. So concentration is what? Concentration is the amount of solute you're dissolving in the solvent. The solute is in mass. Solute is in the form of a mass. The amount we have taken the solute, that is in the form of a mass, which is dissolved in the solvent, which we are taking in the form of a volume. The unit for that volume is dm cube. So such concentrations where solute is dissolved in the solvent, we call that gram concentration. So gram concentration we write down as grams per dm cube, where grams is of solute, right? And this much solute is dissolved in 1 dm cube of solvent. So the first form of concentration we have, that is a gram concentration. Similarly, if we are going to take the solute, if we will be taking the solute in form of moles, if we will be taking the solute in the form of moles, then we will be having solute in the form of moles dissolved in the solvent, in the certain volume of the solvent, which is basically the I've already told you that is the volume of the solvent we take as 1 dm cube. So the concentration will be said to be the molar concentration. Okay, it's said to be the molar concentration. This is type 2, second category of concentration. The first category we call gram concentration, because there we're taking the solute in the form of mass dissolved in certain volume of the solvent. The second type of a concentration is known as molar concentration, where the solute, we take the moles of the solute dissolving in a certain volume of a solvent, which is taken, volume is taken as the unit is taken as a dm cube. Okay. Now these are the two kinds. Fine. For example, if I say I have a sodium chloride solution, I have sodium chloride solution, right? So I can have its concentration as a gram concentration. Okay, I can have its concentration in the gram concentration form, or I can have in a molar concentration form. If I say I have 58.5 grams of NaCl dissolved in 1 dm cube of a solvent, which is water, then this is how I'm going to write it down. This is how I'm going to depict it. It's 58.5 grams of NaCl, which is dissolved in 1 dm cube. But if I am going to take the solute NaCl in the form of a moles, I can write down this as 1 mole per dm cube. That means I've taken 1 mole of a solute, which is NaCl, and I'm dissolving that in 1 dm cube. Now, another very important point is that these two concentrations, they are interchangeable. These two concentrations are interchangeable. Now, we can interchange one form of concentration into another form. Okay, by using the following formula. We will be using the following formula, and that formula is basically moles is equal to mass over AR or MR. This is very basic formula which we use in the calculation of moles. Okay. Now, for example, if I have a gram concentration, let me take the same example. I have 58.5 grams per dm cube of NaCl, and this is my and this is my gram concentration, right? This is my gram concentration. I need to convert this into the molar concentration. Okay, I need to convert this into molar concentration. Now, molar concentration we also called molarity. This is another word. If I say molarity, that means I'm talking about the molar concentration, which is basically moles per dm cube. How many moles are there in 1 dm cube? And I can also represent it by writing capital M. If you see anywhere the capital M written, then that means they're talking about the molarity. They're talking about the molar concentration. That means they are talking about how many moles there are in 1 dm cube. So you need to understand all these terminology. Now, this gram concentration, they want to change into molar concentration. As I've already said that these are interconvertible. You can convert gram concentration into molar concentration. Now, we will be using this formula. I have to convert this mass into what? Into the moles. If I'll be converting this mass into moles, I'll be getting this mass into moles because the dm cube remains the same. If I have grams in dm cube, so the solvent volume remains the same. It's only the gram which is changing into the moles, right? So we'll be using this particular formula. Now let's write the values in this formula and then see how we can convert the mass into the moles. So I need to find out the moles. So my mass is 58.5 and the MR for NaCl is, let's see it over here. NaCl MR, sodium is 23 and the chlorine is 35.5. When you sum it up, we will have 58.5 as an MR of sodium chloride. So 58.5 is a mass you have in 1 dm cube of the solution, and the MR itself is 58.5. So the number of moles will be how much? The number of moles are going to be 1 mole. So basically, if I take 58.5 grams per dm cube of NaCl, that can also be called as 1 mole per dm cube of NaCl. So this is the gram concentration of the same solution, and this is the molar concentration of the same solution. I hope it's clear. So they both are interconvertible. Okay, now I have few questions. Let's start applying that concept of molar concentration and gram concentration into simpler questions, and then we will build up the concept through the application only. Now, the first question, which states that calculate the concentration in mole per dm cube. What they have given you in A, they have given us the mass. They have given us the mass of HCl, and this is dissolved in 2 dm cube of solution. So basically, it's 3.65 grams is dissolved in 2 dm cube, right? And you have to convert it into molar concentration. That means you have to convert it into mole per dm cube. So there are 2 steps you need to follow. Number 1 step, you have to convert the mass into moles, right? And the second step, these number of moles are there in 2 dm cube. So you need to calculate, you need to find out that how many will be there in 1 dm cube. You have to find out. What you will do is that you will divide the number of moles of with 2 and you will get that these many moles are there in 1 dm cube. So let's start calculating, right? Now 3.65 grams of HCl. So how are we going to convert this into moles? We have the formula, again the same formula, moles equal to mass divided by MR. So the what is the mass which is given in the question? It's 33.65. Now, what is an MR of HCl? MR of HCl is basically it's 1 plus 35.5. So MR is basically 36.5. This is my MR. So 3.5, which is a mass, I'll divide by MR. That's 36.5, and I'm getting the moles, that is 0.1 moles. I'm getting 0.1 moles, right? This is the first step achieved. This is the first step which I have achieved. I got the moles, right? Now these moles are there in how many dm cube? They are in 2 dm cube, right? So I cannot write down it's 0.1 mole per dm cube. I need to find out per dm cube. So what I'll do is I will divide the 0.1 moles which are there in 2 dm cube by 2, because I need to find out per dm cube. So 0.1 mole I'll be dividing by 2. So now the number of moles are basically 0.05. These are the moles, and they are in 1 dm cube. They are there in 1 dm cube because these many moles were there in 2 dm cube. So if I need to find out for 1 dm cube, I'll halve the number of moles. Now my concentration will be 0.05 moles per dm cube. So that is how I'm going to convert my gram, the solute in grams, which was there in 2 dm cube, back into the molar concentration, moles per dm cube. This much is clear? So this is the first category. Before this, what we were doing, we had the gram concentration, gram per dm cube, and we were converting into moles per dm cube. But now what is the twist here is that instead of 1 dm cube, they have given us a mass for 2 dm cube. So what are the steps? I'm converting mass into moles, then I'm halving, I'm dividing the moles by 2, because these are the moles in 2 dm cube. So when I divide them, so I'm getting the moles which are 1 dm cube. So that many moles per dm cube is going to be my molar concentration. That is the scenario 1. That's the question number 1. Okay. Now let's move on to the question number 2. Let's see what do we have here. Now it says that this is mass. Again, they have given us the mass of, basically they have given us the mass of a solute, and the solute this time is KOH, right? They have given us the mass of KOH, but how much is the solvent? The solvent is 4 dm cube of the solution. So this is the volume of the solvent. It's the volume of the solvent. This unit tells us that this is the volume. So whenever you have the unit dm cube, you know that it is the volume. Whenever we have the unit gram, we know we are talking about the mass. So we need to calculate the question itself. It's a part of the B part of the question number 1. You need to find out the molar concentration, mole per dm cube of KOH. So that's 28 grams in 4 dm cube, and we have to convert this into mole per dm cube. So we will be following the same steps. Let's see. Let me tell you the steps. So first thing is we'll be converting the mass into moles, and because these moles will be in, they are in 4 dm cube. So what we'll do in the second step, this is the step 1. So step 2, what we'll be doing, step 2, because they are in 4 dm cube, so we will divide the moles by 4, and these many moles will be there in 1 dm cube. And so whatever the moles we'll be getting, that अब हमारे पास ये moles हम लिखेंगे और we'll be getting the answer as mole per dm cube. Let's do the calculation. So let's proceed with the calculation. So 28, using the same formula. What is the formula? We have the formula that is moles is equal to mass over mr. So we need to calculate the number of moles as we have done in step 1. Okay, I have briefed in as step 1. So this is basically 28 grams divided by the mr of KOH. Now mr of KOH is basically KOH. Potassium is 39 plus 16 for oxygen plus 1 for hydrogen. So mr is basically my 56. So the step 1 for calculation of moles is that you need to calculate, no matter how simple is the formula, is the compound, how complicated is the compound, your mr calculation should be correct. If your mr calculation, the value of an mr which you have calculated is wrong, your moles which you are going to derive from that calculation will be wrong. So our first step, you have to be very careful while calculating the mrs. So the 28 grams you're dividing by what? By 56 in order to get into moles, right? You will divide by 56 in order to get the moles. So 28 divided by 56 will be getting how much? We are getting 0.5 moles. But these many moles are there in 4 dm cube. So in order to get in 1 dm cube, what we will be doing, we will be dividing 0.5 by 4, right? So we are getting the answer as 0.125 moles per dm cube. So after dividing by 4, we will be getting the number of moles which will be present in 1 dm cube. So this is how we'll be able to calculate the concentration in mole per dm cube. I hope I'm clear. Okay, this is a very simple form of the question. Let's move on to the next step. Okay, now here I have the question number 2. Now let's see what is the demand of the question. The question says that, I'm reading the question, calculate the amount in moles of the solute. Okay, amount of moles in solute. Now the A part of the question is that they have given you the concentration of the solution as 1 mole per dm cube, and they want you to find out that if we have 250 cm cube out of this 1 dm cube, then how many moles are going to come along with that. Okay, so like for example, if we make a solution, if we make a saturated solution, agar humne saturated solution banaya hai of a this particular substance NaOH, and I have the saturated solution made in the volumetric flask. This somehow the shape of the volumetric, I made the round bottom flask. Basically I have to make in the volumetric flask, right? So मैं अब यहाँ पे shape of the, because ये मैंने draw कर लिया, तो I'm not changing the shape. This is not how we will be drawing the volumetric flask. But ये याद रखो कि ये container in which we have the 1 mole per dm cube, right? So this is 1 dm cube of solvent. In this 1 mole of NaOH is being dissolved, right? Now, for example, for an experiment, we are drawing 250 cm cube out of it. So when we are drawing 250 cm cube for an experiment, then how many moles are coming along with this 250 cm cube? So this is basically how we comprehend the question. Let's read the question once again. So you need to find the amount in moles of a solute in how much? In 250 cm cube. ठीक है, of NaOH solution जिसकी original concentration is 1 mole per dm cube. So we know that we know the conversion of the unit of volume. So we know that we should be knowing it very clearly that 1 dm cube is basically equals to 1000 cm cube. Now here, what is an imbalance in volume? We are taking 250 cm cube, and here we are talking about 1 dm cube. There is a mismatch in the unit. So what we will be doing is that we will be converting this 1 dm cube into 1000 cm cube. So instead of writing 1 dm cube, I'll be writing 1000 cm cube, so that both the units remains the same. So 1000, so instead of 1 dm cube, I write down that 1000 cm cube will be having how many moles? Will be having 1 mole. What I have done right now, I have just decoded this concentration. मैंने जो है right now सिर्फ जो है concentration किसको decode किया है? I have decoded this fact. This is what I have decoded. So instead of 1 mole per dm cube ko, I have decoded in this particular form that 1000 cm cube has 1 mole. Now what we'll be doing on the basis of ratio or the unitary method, if 1000 has these many moles, then the amount which I'm extracting, which is 250 cm cube, will be having X number of moles. So what we'll be doing, we'll be dividing 1 divided by 1000 into 250 cm cube. सही है? So basically अगर हम इसको, now if we are able to see what exactly we are doing, if we are going to generate a formula, if we generate the formula to calculate moles in solution, so what are we doing? This is basically my concentration, 1 mole per dm cube. 1 mole per dm cube I'm writing as 1 mole per 1000 cm cube. So this is actually what I'm writing down. I'm writing down here as the concentration, right? And concentration divided by 1000, right? Because I need to convert this into the same unit of cm cube. And what is this? What is this 250? 250 is basically the volume, right? So this is basically the volume. In the volume in which I need to find out how many moles are going to be there. So this is the volume. So this is basically is the volume. So in order to calculate the moles in solution, I am deriving a formula which is a shortcut formula, which is coming from this particular understanding, so that whenever we need to calculate the moles in solution, our formula is going to be its concentration divided by 1,000 into volume. Why are we dividing by 1,000? Because we get the concentration in dm cube and we get the volume in cm cube. That is why we are dividing this by 1,000 and we are multiplying the whatever the volume is mentioned here, right? Now let's put the values into this formula and see how the calculation, what are the values we are getting. So the concentration was 1 divided by 1,000 and we have the volume as 250. So when we simplify this, we are getting the value, which is basically your, okay, just hold for a second. You're getting the value which is 0. This is 0.25 moles. It's 0.25 moles will be present in 250 cm cube, which you are drawing out for an experiment or whatever the need. Is that clear? So if the concentration is given to us, then we can find out the number of moles which can be present in a specific volume using this particular formula. That's concentration divided by 1,000 into volume. That's a shortcut method when you apply the formula, or you can do it by the reasoning method like I have done here. This is the reasoning method, the way I have done. All right. Exactly the same thing. We need to find out the number of moles in a given volume. So what is the given volume to us is 500 and the concentration is given to us as 0.250 mole per dm cube, right? So here's a mismatch between the units cm cube and dm cube. So if we just straight away put the values in the formula. So let's see, are we getting the answer? So we will be using the formula here, or we can do it by the reasoning. It's up to you. So it's moles equals to concentration divided by 1,000 multiplied by the volume, right? So what is the concentration? The concentration is 0.250, right? And divided by 1,000 because we have the concentration per dm cube. That's a unit. So we are dividing by 1,000. Multiply by the volume. What is the volume given? What are they asking? They're saying that if we have, this is my volumetric flask. If I have, let's say the concentration, I have 0.250 moles per dm cube, right? This is 1 dm cube solvent I have. But out of this, if I want to take out the number of moles which are present in 500 cm cube, right? So I can use this formula. So it's concentration multiply the volume to this volume. I need to find out how many moles will be there. So on putting the values and computing them, I'm getting the answer that 0.125 moles will be present in 250 cm cube. So it's easier to apply the formula rather than doing for your reasoning kind of a calculation. So this is how we can calculate the number of moles which will be present in this volume using the concentration of the solution. Okay. Coming to the next category of the question. Now it says that what is the concentration in mole per dm cube? Now they have given us the mass of the solute, and this is the compound whose moles we need to calculate. It's a very complex compound and we need to find out moles per dm cube. So they have given us the mass in 10 grams, which is present in 250 cm cube, right? And from this, what we have to calculate, moles per dm cube. So the number of steps will be, first of all, the first step, we will be converting grams into moles, right? The second step will be that these moles are there in 250 cm cube. So what we will be doing, we will be converting, whatever the moles we have, we will multiply them by 4 because 250 ka 4 times is 1,000 cm cube. The moles will be multiplying by 4 in order to find out the number of moles which are present in 1,000 cm cube. So that many moles which you are multiplying by 4 per dm cube will be my concentration. So these are the steps we are going to follow. So let's take a start. The first thing is that, very importantly, how we are going to convert the mass into the moles. The mass into the moles we will be using for the first step, we'll be using the formula that's basically moles equal to mass in grams divided by mr. So the first step is very, very important. As I have previously told you that this is a very complex molecule, so we have to take a very utmost we have to be very alert and we have to be very careful while calculating the MR for this compound. So I have already calculated the MR, though it is not part of the question. Okay, it's not given the question, so we have to very alertly we have to calculate. So I calculated it's 392. So the mass we have, that's 10 grams, we will be dividing by 392 in order to get the moles. So the moles I am getting is basically, the moles I'll be getting for this particular part is that's 0.102. Uh, is it 40 grams or it's 10 gram? Okay. What I can do, what I have done here, instead of 10 grams, I've taken it into 40 grams, because 10 grams isn't 250. So 40 grams will be there in 1000 cm cube. You can do it this way as well. Either you do it this way, okay, or you do it this way. Either you convert grams into moles and these moles you multiply by 4, or what I have done, I have multiplied the gram itself by 4 times, and when I multiply by 4 times, and that will be, it actually will be there in the 4,000 in 1000. So 40 into 10 divided by 392, I'm getting 0.102, and these are the moles which will be present in 1 dm cube of solution, and this is going to be my molar concentration. ठीक है, तो यहाँ पर जो आपको, what you have to remember is that whenever we have such a complex compound, you have to calculate the MR with utmost caution. Okay, you have to be very careful while calculating. If your MR goes wrong, then the answer will definitely will go wrong. Is that clear? Coming to the next question, that's question number 4. Now let's see, let's comprehend what are they asking and what they have given. Now calculate the mass of a substance. So that means you have to calculate the mass of the substance in a given volume of a solution. So what is the given volume? It's 50 cm cube. You need to find out how many, what is the mass. They're asking in grams, they're not asking in moles. And what they have given you, they have given you the molar concentration. Say, but what is the demand? They're asking you the mass. So from the molar concentration, they have given us the molar concentration. First thing is we are going to decode it. So is basically we have basically, so we will we in the 1000 cm cube, which is basically taken as 1 dm cube, we will be, in order to make the unit same, we are converting 1 dm cube into 1000 cm cube. So 1000 cm cube has 0.5 moles. Okay, that is how we have decoded the concentration. 1000 cm cube has 0.5 moles. So out of this 1000 cm cube, when I'm taking just 50 cm cube, then how many moles are going to come along with this 50 cm cube? Okay, so we can straight away use a formula, that's concentration divided by 1000 multiply by volume in order to get the moles. Either this or this. Okay, either we can use this or we can have this. We can straight away go for a formula, right? So we will be, agar hum reasoning se kar rahe hain, then we will be 0.5 divided by 1000 multiply by 50 is the same. What we will be, this is the concentration and this is the volume. So concentration multiplied by volume will be getting the moles, right? So the moles I'm getting is basically 0.025. Okay, so this is what I am getting, 0.025 moles, which is there in 50 cm cube. Right now, what I have to do is I need to find out the mass, so that these moles I'm going to convert into mass, right? Because they're asking me to give me the mass in 50 cm cube. So we know there's another formula for that. If we need to convert mass or moles into mass, the formula is moles equal to mass over mr. If we rearrange this formula, We can find out the mass is equal to moles into mr. Okay, so we have the number of moles here, that's 0.025, and we'll be converting, multiplying this by mr. So what is the mr for NaCl? The mr for NaCl is basically, the mr for NaCl will be, it's 23 plus 35.5, which is basically my 58.5. So 0.25, I'll be multiplying by 58.5 in order to convert into mass. So mass is basically, when you compute it, I'm getting answer 1.463 grams. Okay, when we multiply my number of moles with mr, these many grams will be present in 50 cm3, which I'm drawing out of the concentration of 0.5 mole per dm cube of NaCl. Okay, so these are the steps, right? Let's proceed. Let's see which question do we have next, and that's the last category. And this category is basically which we are getting in the ATP paper. So these are the calculations which are related to our titration questions, okay, which are related to the titration question. Now in this particular question, let me explain you first what's happening, and then we'll move on to the question. Now when we talk about the titration questions, in the titration question, these are the apparatus we actually use when while doing the titration. Titration is basically is a method where we perform neutralization reaction, okay, where we perform neutralization reactions of an acid with an alkali. Okay, acid and alkali आपस में एक दूसरे को neutralize करते हैं. So we can have in the burette either an acid or an alkali, and in reverse, similarly, if we are taking an alkali in this, the reverse chemical, that means the acid will be there in the conical flask, and we are going to measure this chemical which we are going to have in the conical flask, or it can be basically the beaker. Okay, it can be basically the beaker. So whatever the chemical we are going to add into the beaker, and that has to be that should be measured through the pipette, right? That should be measured through the pipette and should be added or poured into the conical flask. So this is a chemical, and then we need to add the indicator. Now through this titration experiment, what are we actually achieving is that there we have two chemicals. Let's say we have chemical A and we have chemical B. इन दोनों chemicals में से किसी एक की complete information हमें मिली होती है. They give you complete information, they give you volume, because these are the solutions. So whenever we're talking about the solutions, we are talking about the solute and we are talking about the solvent, right? And in order to calculate the moles of the solution, what we have to do is, we know we have derived the formula, and that formula was concentration into volume, concentration divided by 1000 into volume, in order to calculate the moles, right? So and we are performing the neutralization reaction between acid and alkali. So acid ke H positive ion should be neutralized or should be cancelled by OH negative ion on the basis of the ratio. ये सारी calculations में करते हैं. अब हम करते क्या है? What do we do is, now we have two chemicals, we have A and B. A can be acid or an alkali, and reverse can be a B. Now, किसी भी एक chemical की, any one of the chemical, we need to have the complete information. What do I mean by the complete information? That means I need to have a volume as well as the concentration known of the substance. Right? Now, what do they do with the B substance? In the B substance, they keep one of these quantities unknown. They either the volume is unknown or the concentration is unknown. Okay, either one of them is unknown. So what do we do? How do we go about with the calculation in order to see how much chemical is neutralizing, how much chemical of A is neutralizing, how much chemical of B, or if the concentration is unknown, then this much volume or this chemical with this much volume has how much concentration. So what do we do is, when we have two chemicals, we look for a chemical whose both complete information we have. whose complete information we have in terms of volume and concentration, right? Now, what do we do is that when we know the concentration and volume of the chemical, we have identified who will be calculating the moles of that. How we'll calculate the moles? Moles formula lagayenge, concentration divided by 1000 multiplied by the volume. We have the number of moles. This is step one. Then the step two, let's suppose hum ek volume find out karni hai, concentration is given to us of the substance B. Now after this, what we will be doing, kyunki hame molar ratio ke basis pata karna hai, so we will be writing the equation, or the equation will be given along with the question. Okay, either the equation will be given in the question, or they have given us the molar ratio in the question. Either they have given us the equation in question, or they have given us the ratio, the molar ratio. Okay, how many moles of A will be reacting with uh, B. Either of them they have given. ठीक है. Now अब हमारे पास ये moles आ गए. अब हमारे पास इन्होंने आपको equation दी हुई है या जो भी दिया हुआ है. They're saying that 1 mole of NaA is combining with 1 mole of B. Right? So whatever the moles you have calculated here, let's supposing अगर हमारे पास है 0.01 moles, तो 0.01 moles because the ratio is same, so B के भी इतने ही number of moles इसको neutralize करेंगे, उसके effect को cancel out करेंगे. अगर H जो है वो acid, A जो है acid है और B जो है वो alkali है, तो 0.01 H positive ions will be cancelling the OH negative 0.01 of the OH, right? So we know that on the basis of the ratio, we know the number of moles of the B which are reacting with A. Now, when we know the number of moles of B, we have found, हमने निकाल लिया through the equation of the molar concentration. Now the step C will be, the step 3 will be, we know the moles, right? We need to find out what the volume. So using the formula, the concentration is already given to us. So whatever the concentration they have given us, that given concentration we'll write down here, divide by 1000, and we will find out the unknown volume. सही है, unknown volume आप निकालेंगे by rearranging this formula. So how we'll rearrange the formula? So we'll have volume is equal to moles multiplied by 1000 divided by concentration, will get the volume. So this is this kind of a question, which are your titration based question, which comes in the ATP. So these questions, or they comes in the theory, right? So these questions are your 3-mark questions or a 4-mark question. Now 3 marks which the examiner, if in P2 they give this kind of a question, there are 3-mark question, right? So the first mark is to calculate the moles of the reactant whose volume and concentration is given to you. The second mark is for, in order from the equation, to find out the molar ratio between the two reactant. And the third mark is to find out whatever is not given of the substance B on the basis of the molar ratio and the concentration which is given in the, or the volume given in the question. So this is how you get the 3 marks. Now, this is all about the paper 2. The paper 2, you get normally these questions for 3 marks. Now, let's proceed that if we get the questions in the MCQ, we have a very limited time. There, one question we normally try to give, we try to solve in 1 minute. So we have basically 40 questions which need to be actually solved in 40 minutes. So you have the remaining 20 minutes for the review. So we need to have the shortcuts. If we have a similar question coming in MCQ and we are being awarded 1 mark, then the shortcut is that we use the formula. अगर आप ये formula paper 2 के लिए apply करते हैं, because this formula give you direct answer. It give you direct your answer. It doesn't give you the values of the intermediate steps. So you will be, if you will be using this formula for solving your P2 questions, you'll be just getting 1 mark there. Now let's see what is the formula. Formula is MV over N of an acid, right? We are talking about the neutralization. And there we have MV of N of an alkali, right? So what does M stands for? M, as I already told you, it stands for molarity. It stands for molar concentration. Okay, it stands for molar concentration. It stands for mole per dm cube, right? What V stands for? V stands for volume. What N stands for? N means the number of moles which are coming from equation. Now, for example, if I have HCl reacting with NaOH, so I'll be getting the compound, the product as NaCl plus H2O. This is my balanced equation. So the value of N, I'll be writing it down as the value of N. I have 1 mole here, 1 mole here. So in this scenario, if I'm taking this scenario, the value of N is going to be 1 and 1, right? But if the scenario changed and I have sulfuric acid reacting with NaOH, so the product which will be formed is going to be Na2SO4 and H2O. Now, when I balance this particular equation, I have H2SO4 reacting with 2 moles of NaOH. I'm getting 2. So there the ratio is 1:2. Now, what will be the value for N for the second scenario? For the second scenario, the volume of N will be acid ke kitne moles hai? The value of N will be 1, and the value of alkali, because this is what I have, the value of an alkali. So this is basically going to be 2. Sahi hai? Is it clear? This much is clear? All right. Now we have the formula, the these variables you are clear about now. अब इसके अंदर क्या होता है कि जो भी quantities आपको दी हुई हैं, let's suppose उन्होंने कहा कि find out, I'm just making up the question, find out the volume of acid which reacts, acid of concentration, let's say 0.5 mole per dm cube, which reacts with, which completely neutralizes, let's say 25 cm cube of 0.1 molarity of NaOH. So let's suppose this is a question. Now what we need to find out, we need to find out the volume of an acid, right? So let's write down the formula. So we need to find out what is the molarity given to us. It's 0.5. So molarity I'm writing as 0.5. Volume is unknown, so I'm writing V over here. What is, because we are dealing with अच्छा now एक यहाँ पर मैंने वेग ले लिया है. This is, let's suppose this is my sulfuric acid H2SO4. fine. तो sulfuric acid का यहाँ पर रेशियो जो है वो है 1. This is for an acid equals to, now I'll have the values for an alkali. What is the concentration of an alkali? Is 0.1, 0.1. And what is the volume? It's 25 cm cube. 25 cm cube over the number of moles of an alkali, that's 2. So I'll write down 2. Now we have to rearrange this and calculate the value for V. So it's going to be 0.1 into 25 into 1 over 0.5 into 2. When we compute this, we will be getting the volume in cm cube. But here the examiner is not giving you the marks for the formula. He's not giving you the marks because you're directly putting the values in the formula and eventually using their calculator value to write the answer, or to get see what is an option A or B or C or D. So intermediate steps आप नहीं कर रहे हैं. So here, if you're going to use this formula, you'll be just getting 1 mark if your answer is correct. But when it comes to paper 2, the paper 2 questions, similar questions are 3-mark question. There you have to go step by step. Is that clear? Now, what are going to be the step by step scenario for this? इसके अंदर step by step scenario क्या होगा? Let's go ahead. इसके अंदर हम step by step scenario करते हैं. Step by step scenario में क्या करेंगे? मैंने यहाँ पर वैल्यूज नहीं लिखी हैं, और आप अपना इसको अभी इसी को कैलकुलेट करके दोनों चीजों को आप चेक कर लीजिएगा. ठीक है. नाउ अब व्हेन विल बी, लेट्स सपोज दिस क्वेश्चन इज गिवन टू यू एज अ question 2, paper 2 question. So we will be starting with the chemical whose both the values are given to you. ओहो, मैंने बाकी का भी रेस कर दिया. Where find the volume of sulfur which completely neutralizes 20 cm cube of 0.1 molarity mole per dm cube of NaOH. ठीक है. तो इस ये वाला केमिकल है whose both volume and concentration is given to you. So we will find out moles equal to volume into concentration divided by 1000. We will be finding out the moles of the chemical whose both the quantities are given to you. So this is going to be 20 multiplied by 0.1 divided by 1000. Whatever the value you have, ठीक है, जो भी वैल्यू आपकी आ रही है वो आपके आ गए मोल्स, ठीक है। नाउ दिस इज स्टेप वन. If the correct answer is there, you'll be getting 1 mark here. Now the second step, you will be finding out the ratio between sulfuric acid and NOH, right? So how you will be doing? You will be doing through equation. So this is an equation. So I know that the ratio between this is 1:2 because I know I've written down the balanced equation. So whatever the moles you're getting here, let's say I am getting X number of moles. So whatever the moles you're getting here, तो NaOH के हो जाएंगे 2x moles, ठीक है। अब ये जो moles आ रहे हैं, अब ये जो moles आ रहे हैं NaOH के जो आपने निकाल लिए हैं, अब NaOH सॉरी, आई मीन आई हैव डन वन मिस्टेक। ये जो मोल्स आपने कैलकुलेट करे हैं ये NaOH के करे हैं और अब आपको सल्फ्यूरिक एसिड के निकालने हैं, ठीक है। तो अब आपके पास ये जो यहाँ पर NaOH के जो मोल्स आ रहे हैं ये X है और सल्फ्यूरिक एसिड के हो जाएंगे X/2, ठीक है। अब X/2 जो हो गए वो सल्फ्यूरिक एसिड के मोल्स हो गए, इसके लिए एग्जामिनर आपको 1 मार्क देगा, ठीक है। अब आपको क्या निकालना है? थर्ड स्टेप में यू नीड टू फाइंड आउट द वॉल्यूम. द थर्ड स्टेप यू नीड टू फाइंड आउट द वॉल्यूम. नाउ अगेन विल बी यूजिंग द सेम फॉर्मूला, दैट्स मोल्स इक्वल टू वॉल्यूम मल्टीप्लाई बाय कॉन्सेंट्रेशन डिवाइडेड बाय 1000. तो ये आप यहाँ पर इसको फाइंड आउट करने के लिए इसको रीअरेंज कर लेंगे क्वेश्चन को. सो दिस इज गोइंग टू बी मोल्स वट एवर यू हैव. द मोल्स हमारे पास क्या आ रहा है? लेट्स से मोल्स हमारे पास X/2 आ रहा था, ठीक है। चूंकि मैंने कैलकुलेट नहीं किया, लेट्स हैव इट एज अ वेरिएबल, मल्टीप्लाई बाय द 1000 डिवाइडेड बाय द concentration which is given to us as 0.5. So when we'll do this, we'll get the volume in cm cube and there you'll be getting the third marks. और अगर आपको इस अपने आंसर को चेक करना है तो आप स्ट्रेट ये वाला फॉर्मूला लगाइए, सारी वैल्यूज डालिए और अगर आपका आंसर सेम आ रहा है so that means you have all your steps are correct. So for paper 2 we will be following the step by step process. For paper 1 we will be following the formula. Now for the paper 4 में यही questions आपके guided question होते हैं. They take you step by step. तो जिस तरह से भी steps दिए हुए उन्होंने उसी को follow करते हुए you will be arriving to the answer. वहां पर आपको guided steps मिलते हैं, उन्हीं guided steps के हिसाब से आप आगे proceed करते जाएंगे, ठीक है। Now let's see what further we do have here. आगे हमारे पास क्या है यहाँ पर? Okay, this is the question which has been given to us. इस question में इन्होंने कहा है calculate the molarity or the molar concentration of NaOH when 25 cm cube react with 17 cm cube of this mass concentration. तो इन्होंने सल्फ्यूरिक एसिड की दोनों चीजें दी हुई है, वॉल्यूम भी दिया हुआ है, कॉन्सेंट्रेशन. तो स्टेप 1 जो नोन है, जिसकी नोन ऑल द क्वांटिटीज आर गिवन, वी विल बी स्टार्टिंग विद दैट. हम इसके नंबर ऑफ मोल्स निकालेंगे. तो व्हाट वी विल डू, वी विल बी मल्टीप्लाइंग द वॉल्यूम with the concentration 0.1 and will divide that by 1000. तो हमारे पास moles of sulfuric acid आ जाएंगे, known which is basically both the quantities of sulfuric acid is given, ठीक है। तो आप इसको मल्टीप्लाई करेंगे तो फिर आपके पास जो है वो आंसर आ जाएगा. So here the answer is coming, that is basically we are getting 1.7 into 10 raised to power minus 3. The step 2 we will be writing the equation in order to get the molar ratio. ठीक है, molar ratio. अभी मैंने पिछले स्लाइड पे आपको दिखाया था कि sulfuric acid and NaOH they react in the ratio of 1:2. और हमें कैसे पता चला था? ये हमने इक्वेशन से निकाला था. ये सल्फ्यूरिक एसिड के मोल्स हैं 1.7 into 10 raised to power minus 3. तो NaOH के कितने हो जाएंगे? 2 times 1.7 into 10 raised to power minus 3. ये NaOH के मोल्स हो जाएंगे. अब हमें निकालना क्या है? हमें कॉन्सेंट्रेशन ऑफ NaOH निकालना है, वॉल्यूम आपको दी हुई है. अब आप थर्ड स्टेप के लिए दोबारा से फॉर्मूला लगाएंगे. तो फॉर्मूला है मोल्स इक्वल टू कॉन्सेंट्रेशन डिवाइड बाय 1000 मल्टीप्लाई बाय वॉल्यूम. अब यहाँ पर आपको मोलारिटी निकालनी है, ठीक है, मोल्स निकालने हैं. तो कॉन्सेंट्रेशन उन्होंने आपको दी हुई है, कॉन्सेंट्रेशन निकालनी है. मोल्स आपको पता चल गए, these are the number of moles you are getting, that's 1.7 into 10 raised to power minus 3 multiplied by 2. These are the moles. You need to find out the concentration, divide by 1000, and volume they have specified it's 25 cm cube, ठीक है. So multiply by 25 cm cube. So अब आप concentration जब आप उसको compute करेंगे तो concentration आ जाएगी आपके पास 0.0136 moles per dm cube. So for this particular question, examiner will be giving you 3 marks. 1 mark is for this part where you're calculating the moles of sulfuric acid. Another mark is for the molar ratio, and the third mark is for the final answer. इस आंसर को आप टैली और चेक कर सकते हैं by the formula m over v, m into v over n of an acid equals to mv over n of an alkali. और यहाँ पर आपका आंसर जो होगा वो सेम आएगा, ठीक है। तो आप अपने क्रॉस चेक कर सकते हैं, लेकिन अगर आप फॉर्मूला यूज करेंगे यू विल बी जस्ट गेटिंग 1 मार्क. Now here I have given you another question. Try out this question. The answer for this question is mentioned here on the slide, is 0.118 moles per dm cube. Read the question, comprehend the question, and here are the guided steps which are mentioned, right? Take a minute, read the question, and see, are you getting the right answer or not? Try it out both the ways, using the formula and using the 3-step method, which will be incorporating in the paper too. That's all for the moles in solution.